The first bit of energy involved in the production of wind power is just that, the wind blowing. The wind is a form of kinetic energy because it's energy in motion. This presentation will attempt to show you how that kinetic wind energy is converted into kinetic mechanical energy and then into electrical energy, with an emphasis on all of the systems that help to aid this process. When the wind begins to blow across the wind turbine, the anemometer and weather vane on the top of the nacelle measure the wind speed and wind direction. So what is to be done with these measurements? The weather data is sent through the wind turbine to the wind farm computer systems. You can refer to these computer systems by the name of SCADA, which stands for Supervisory Control and Data Acquisition. If you break down the words in the SCADA acronym, you can start to get an idea of what this system is all about and how it might be used on a wind farm. Now back to our flow of wind power. The computer SCADA software will process the recorded wind data and return a digital signal back to the turbine's electrical control system. These electrical control systems are known as PLCs, or Programmable Logic Controllers. The job of the PLC is to convert the digital computer signals sent from the SCADA into electrical signals, which then trigger mechanical action to both yaw the nacelle and pitch the blades into the wind. This all according to the original weather data that was measured by the wind vane and anemometer. Get it? So far we have covered the basic loop from kinetic wind power to mechanical action, which in reality all happens very quickly. The wind turbine should now be catching some wind and beginning to spin. This cycle is constantly monitored, sending SCADA signals back and forth and telling the PLCs when and where to send an electrical current to engage the mechanical systems to then adjust the turbine. These adjustments are accounting for the ever-changing weather in order to maintain optimal efficiency, because consistent power output is very important. Inside the turbine, the components work in order, starting from the blade assembly and mechanically progressing all the way through the nacelle to the generator. The generator is, of course, where the conversion of kinetic mechanical energy to electrical energy takes place. There are several sensors and monitoring devices throughout the turbine collecting important operational data from several turbine components to be processed with that SCADA system. The SCADA reads the data and returns a digital signal to the turbine's PLCs, which again convert that signal into an electrical signal, which then triggers a mechanical action to adjust the nacelle's components for improved efficiency. When a turbine is working efficiently, the turbine's generator sends the converted wind energy to the transformer. The transformer, which could be located outside of the turbine, in the base of the turbine, or even in the nacelle, steps up the newly created electrical power so it may be effectively transmitted to the next stage. There are additional sensors and monitoring devices within the transformer that measure and record the power information as it is being stepped up. Again, this data is sent back through the SCADA system and on down the line to trigger mechanical action to control the output of the transformer to the next stage, which is the substation. By now, you should be starting to understand that a wind turbine consists of many different systems working together, and the consistent communication between these systems is critical. The substation's function is to collect the power flow from every turbine on the wind farm and transforms the combined power into usable electricity for distribution onto the electrical grid. The grid is a flow of alternating current that must be maintained at a constant balance in order to work predictably without fail. The substations are equipped with further sensory and monitoring devices to ensure the output is in proper balance to match the grid. Another feature of the computer SCADA system linked to the various devices of a wind turbine and wind farm is to automatically send warnings and alerts to the on-call technicians when issues occur. Some of these alerts are minor issues that can be scheduled for maintenance, and some are alerts that are due to major problems that must be dealt with immediately. Additionally, every bit of SCADA data is collected and analyzed, whether the turbine is running smoothly or having issues. This data is then used for the engineers and technicians to better use, understand, and maintain these machines.